The focus of the project was what we call mobility imbalance, but let's start to understand what we mean by this kind of informal term. The idea is the following. There are areas of the cities that if you want to travel between two areas, sometimes it's very easy to do it by car. If you have a car that is a completely flexible way of moving around, you can decide when you start. And typically the travel time tend to be quite short because you can choose the shortest road distance. Or otherwise, you have to use public transit, possibly integrated with walking to the closest transit station or biking. So sometimes, and we define imbalance, this notion of you have a big difference between the travel time by car and the travel time by transit. And of course, if there is a big difference, that can be a problem because you might be induced to use the car for that trip. And we know that, that would generate traffic, would increase, carbon emissions, because by far transit and active mode of transportation are the most carbon efficient. So that is going to be a big problem for the city. So the goal of the project was to try to analyze the different transit networks and road networks of the city and accessibility by bike and walking to understand whether we can find these imbalance points. So the idea was to, as Umberto just said, to use novel network and topological-based methods. Here there is a weird word which is persistent homologies. Don't be scared. It's just a term in topography in topology studies. But basically the idea is to find holes. Okay, you can think of these as a fancier name of a hole. Okay, so what we did, we overlaid different networks in the city, the road network, the transit network divided by bus and subway and so on and so forth, and we tried to find holes in the network overlaying the different type of transport modes. So we also found some challenges. The challenge, most importantly, was to find detailed demand data to cross the analysis, the topological analysis with demand. Because of course, when you find a hole or a mobility imbalance, that might be because there is no demand for that particular trip between two areas of the city. Always there is a chicken and egg problem. Maybe there is no demand because there is no possibility of going fast from A to B. You never know. But if you identify an area where there is a lot of flow between two places and there is a high imbalance, those are places where the city might want to intervene because maybe there is a demand for having an additional bus line, for instance, directly between these two cities. Unfortunately, finding data is not always easy, and that is in a sense connect to what you discussed earlier in the panel this morning. You say, a common way of collaborating would be exchanging data, and I totally agree with that. Researchers like us most of the times try to work with real data, and in this specific case, the challenge was how can we identify detailed demand data. We try to use different sources of data like Uber movement data that give you an idea of where Uber requests are in a city. And you can think of Uber requests as a way of identifying areas of demand that is not covered maybe by transit, and then people try to take an Uber. That was the idea, but the data was not very detailed. At the end of the day, what we decided was to just focus on the topological properties and leave, in a sense, the estimation of demand for further steps because we couldn't do in the project given the lack of data. We start analyzing using existing tools, but most importantly, combining them into a single web tool that then, as Lucas knows, we try and we are actually delivering to the city as a way of analyzing these mobility imbalances in the city. So here just an example of what we did for public by parking locations and also Transilect. This is near the region of Scista. This is interesting map, and in a sense, it's stating something that is very intuitive. So when you analyze this notion of imbalance, so basically the difference in travel time between going by car and going by transit, of course, the lowest differences are close to the transit lines. That's quite obvious. But in a sense, that also give you an idea of where might be difficulties in traveling. For instance, it's very easy to travel to the center from basically anywhere, but it's very difficult to travel, let's say, from north to south or vice versa. This is kind of a problem typical in many cities, not only in Stockholm, where, for instance, subway lines are designed basically to go to the center and back, which is also related to maybe an old-fashioned way of working, where you have the central business district. Everybody goes to the central business district with the subway and then go back. Now there has been COVID. People might want to work from home, or you might want to have a new center in Kista. And so the transit network is no longer, satisfying those needs. And this is just a snapshot of the web tool that we have designed to identify these topological holes that you can see on the left. You see different different modes of transportation that you can activate or not. One important point when you use transit is also the starting time of your trip, because, for instance, bus line, they're not always there. If you're aligned with a bus starting at your bus stop, your travel time is shorter, and that basically tells you that the travel time from A to B really varies a lot when you have to rely on transit, which is a problem because it's not a good competition with the car that you can start whenever you want. I try to be very fast, so thank you for the presentation. Thank you for your attention. If you have any questions, I'll be glad to answer. Thank you.